Good afternoon, ladies and gentlemen, and a very warm welcome to Reimagining Tech in 2022, presented by Google Cloud and ETCIO. To help IT decision makers in meeting digital transformation goals for their organizations, ET and Google Cloud have come up with an innovative series of 10 workshops around cutting edge cloud technologies. The sessions have been conceptualized keeping in mind IT leaders who are looking to gain actionable insights to support their organization's digital growth strategies. Today's workshop is on the topic fast tracking AI and ML to gain competitive edge, easing the process of developing, training, and deploying AI and ML models at scale is key to fully exploiting the value proposition it offers. The ability to scale AI at speed can provide a distinct competitive edge and differentiate companies that realize value from their AI investments from those that do not. The workshop will explore how technology leaders can quickly and easily manage as well as scale AI models. Ladies and gentlemen, we will also have a Q&A session at the end of the workshop, so you can keep posting your questions and our speakers will be happy to take them up. Now let's kickstart today's event. I would like to invite Himanshu Rastogi, Chief Technology Officer, Medi Assist, to share his vast knowledge with the audience. Pleasure to have you here, Himanshu. Over to you.
Artificial intelligence is one of the biggest disruptions in the recent times. While it sounds like a cliche, it is true. It is not new and has existed for decades, but now with better compute and infrastructure available, it has become a lot more accessible and it's finding use cases which can be practically solved and deliver results. Whether you are using machine learning, deep neural network, or anything else, there are two broad categories of people by my experience. Number one, who are in build state. Basically, you are thinking about how to use these technologies to solve a business problem that you have in hand. Number two, people who have just deployed into production and have not seen what does it take to keep on running in production in 3 months, 6 months, or 12 months. Apologies, but I have ignored set of people who have been running this in production for years because I know that by this time you guys would have experienced all the challenges and you would know how to solve them at back of your hand, while others can learn from my experience. In order to start how these two category of people should handle the questions that they have, I'll cite two examples so that it becomes a lot more relevant and you understand what I'm going to cover up in next few minutes. Example number one, there is iRobot, which basically became a lot more popular during COVID times and used for cleaning carpets at home versus a driverless car. Both run on simple artificial intelligence. When they find an obstacle, they find another path. And then once the work is done, they dock themselves. Second one, rain forecast versus stock price move. These two are very relevant and I just wanted to get your attention because based on training data, efforts gone, and confidence which your team have, impact of the solution can be very, very, very different. And the level of carefulness that you need to have before you deploy into production can drastically vary. So irrespective of what category you belong to, please build safety nets. There is no excuse for that. You would, by your experience, find that in your own business. It could be using human in the loop at the least. For set of people who are in build set, that was category one, which I stated earlier, I would suggest the following route. Number one, start with a stable platform, cloud or self-managed, and use packaged software. Do not try to pick up everything which is available on internet. Number two, experiment with human in loop in initial days to avoid anything going drastically wrong, which can impact your business. There has been instances wherein companies have lost millions of dollars because model was misbehaving. Number three, when you understand the complexity and have a grip, then move to your infrastructure and have your own team manage it. While I have listed number three, it could be totally optional and should be exercised only if you think you are in better control or there are pressures on cost or scaling, then only you should get onto an environment which is managed by you. For the second set of people who are ready to deploy or have just gone into production, I have a slightly longer list. Please keep these things in mind. Number one, feature set and design. Data sets will change and evolve as more observations get added or business gets wiser, which is very with every day passing in, business finds out new nitty-gritties and new variables. Second, because the feature sets which you have arrived by training previous models are embedded into your previous training jobs. So if you are training the model when the new data set arrives, it can become slightly challenging. I would recommend to use a feature store. Feature store is referred as a centralized operational data management system that allows data teams to store, share, and use curated set of ML projects. This will assist to maintain all historical data along with most up-to-date values in time-consistent manner. This makes comparing feature values and model performance as easy as an API call. Number two, minimize work duplication in the sense that all features stored in the centralized location are easily accessible to internal teams within the organization. Second thing which you have to keep in mind would be distributed ML system, commonly known as parallelism. Consider both data and model parallelism. Hadoop and Spark would be good choices if you are designing a system or you have ability to change the system. Model parallelism will not only help you if data is sequential, access to data is sequential. So please ensure that data is distributed because tomorrow when the data increases, both data as well as model should be able to scale on its own. Number three, which would be use containers to encapsulate versioning issues. When you will start using a lot more models, there would be issues, what we call it like dependency health or package versioning. In order to avoid them, use deployment units like containers to have a self-sustained unit which can be deployed as and when you require. Last, GPU and Google TPUs are better choices over CPUs because of sequential processing nature, which typically is common with CPUs. GPUs and Google TPUs are better for parallel nature of processing. These are four things, just repeating it again: feature set, design and storage, distributed ML systems, commonly known as parallelism, containers to encapsulate versioning issues. Number four, use GPUs and TPUs, which are better over CPUs. We at Medi use ML and AI for three large use cases. Number one, document classification to ensure that dockets related to hospitalizations are complete. We do get a lot of images, which basically unstructured data, which people either click from their camera phones or scan and send it to us. It is important for us to figure it out whether this docket is complete from all aspects, because one document missing would mean that I have to go back to the customer to get that extra document. We use artificial intelligence to actually figure out what all kinds of documents exist in that docket and flag off very early in the cycle. Number two, we use to predict fraud, abuse, and waste in a hospital bill, which we have trained our models from our historical data to avoid any kind of excessive billing. This could be intentional or unintentional, but we use technology to actually figure out any kind of anomalies. The most recent one is most exciting, which I am personally excited about, and I am personally overlooking at the project. We are trying to predict the hospital bill much before the hospital generates the bill. We are able to do this because we process roughly around 35 lakh inpatient bills on a yearly basis. And over the legacy that we have, which is more than 20 years, I can actually predict based on length of stay in a hospital that what would be probable bill. We are currently running with plus minus 7% error rates, and we are training our models again to get that even lower. What we want to do is we want to ensure that member has the best experience, avoids any hassles, and for hospitals, we free up the bed much earlier. Thank you.
Thank you, Himanshu, for sharing valuable insights and learning with the audience. Artificial intelligence is presenting businesses with limitless possibilities, right from solving real world problems to driving innovation and creating new revenue opportunities. Even as organizations are realizing the transformative impact of AI and the possible business use cases, they have only managed to scratch the surface of the technology's far reaching capabilities. To elaborate this further, we have our next keynote address by Ravindra Yadav, Senior Director, Data Science, Meesho. Welcome, Ravindra. We are delighted to have you here. Ladies and gentlemen, before we start the next keynote session, a quick reminder to drop your session-related questions in the chat box. We'll pick the questions at the end of the session. Our experts would love to take up the questions. Now let's start this session. Over to you.
Hi everyone, I am Ravindra Yadav, Senior Director of Data Science at Meesho. I lead the ranking and relevance charter, largely solving for conversion, freshness, and quality. Prior to Meesho, I have experience working with Flipkart, Hike Messenger, Goldman Sachs in the domain of data science. I'll take a minute to talk about Meesho. We are an e-commerce platform that undertakes retail distribution, enabling small retail merchants to connect and sell their products online. We are the world's most downloaded shopping app with roughly 125 million monthly active users. We aim to create an environment where everyone can start their business with nearly zero investment. Our vision is to enable 100 million small businesses to succeed online and bring e-commerce to the next billion Indians. We are extensive users of data science and machine learning. Among other things, we use it to offer personalized discovery of feed and product recommendation based on users' preferences, a chatbot that provides step-by-step onboarding and query resolution, voice and image-based search, automated product cataloging for sellers, a price recommendation engine to help sellers price their products right. So today I'll share some insights about how we have scaled up our DS operations from our humble beginnings and our current approach and philosophies for ML. The value of data is tremendous, and any business model requires data to drive decisions and make projections for future growth and performance. Companies have begun to utilize machine learning and artificial intelligence to learn from this data and harness it for predictive analytics. This shift, however, comes with significant challenges. Despite the vast potential of AI, it hasn't caught hold in most industries. The majority of AI projects hit a wall. There is an estimate that the majority of companies' AI projects are in the proof of concept stage, and most enterprises fail to scale AI deployments across the organization. So I'm going to focus on two important questions here. How to build custom AI models at speed, how to move AI into full-scale production and accelerate deployment of predictable ML in production. To start off, let's look at the roadblocks to fast deployments in the first place. Almost 50% of AI ML initiatives don't even make it from prototypes to production. The culprits: poor quality data, very few established standards for developing AI ML models. There are endless combination of compute options that a data scientist can utilize for different AI workloads, including CPUs, GPUs, AI accelerators, cloud, on-prem, hybrid cloud, and others. Then there's a skill gap. Data scientists are skilled mathematicians, statisticians, but in order to successfully bring models to production, they also need experience in software development and DevOps. Models are often created from scratch without consistent software development lifecycle and processes. Very minimal testing procedures, or KPIs for measuring the success of these models. Moreover, a large amount of time is expended as a result of repeatedly training ML models with fresh data through the development cycle. This is because of data quality degradation over time as well. Due to complexities inherent to ML, iterating on models and continuously deploying them to production tends to be time consuming and error prone. How do we solve this? One of the emerging ways to counteract this is using ML ops, machine learning operations. ML ops is a set of practices for collaboration and communication between data scientists and engineers to automate the deployment of machine learning and deep learning models in large-scale production environments. MLOps adopts some best practices from DevOps, example using agile methodologies instead of the waterfall methodology. Why do we need MLOps? Building ML models and code represents a small fraction of the components that comprise an enterprise production deployment workflow. To operationalize ML models, data scientists are required to work closely with multiple other teams, such as business, engineering, and ops. This presents organizational challenges like communication, efficient collaboration, and coordination. So the goal of ML ops is to streamline such challenges using well-established practices and bring agility and speed. Let's look at how this specific problem MLOps is able to solve. First, it helps in automating ML pipelines. ML pipelines contain long and resource-intensive processes, collecting data, training models, experimentation with different networks, unit test, integration test, and bias removal before deploying. Performing these steps manually is slow and error-prone. MLOps tools automate these steps and provide a reliable, reproducible process. The second aspect is monitoring. There are degradation in performance and drift in results over time in all models. This needs constant drift detection and retraining with more complete or fresher data. MLOps tools provide monitoring and alerting capabilities whenever such drifts are happening. Then the third point is experiment with newer models. MLOps also enable us to build on monitoring, do retraining, try out different algorithms in an experimental setup, and take a call to roll out the best performing ones. Now that we have discussed the technical aspects of developing and training models at speed, let's take a step back and discuss something more fundamental. How do we train high quality models based on business needs? Training high quality models specific to business needs. In general, the technical aspects of how to build and optimize models are well documented, but very few resources are available on how developing machine learning models fits within a business context. The questions that organizations face are: when is it a good idea to use machine learning? How to get started? How to update a model over time without breaking the product? A few checklist items while building an ML model. Understand the business problem and define success. This sounds cliche, but it's tempting to spend lots of time on a flashy ML algorithm without assessing whether we need it in the first place. So the first phase of any machine learning project is developing an understanding of the business requirement. You need to know what problem you're trying to solve before attempting to solve it. To start, work with the owner of the project. Make sure you understand the project's objectives and requirements. The goal is to convert this knowledge into a suitable problem definition for the ML project and create a preliminary plan for achieving the project's objectives. This will seem like a very lengthy process with many questions to answer, but will greatly increase the chance of overall project success. Second point, determine the model's feature and start with the basics. Once the business needs are identified, we need to determine which ones we should or we can solve with ML. A basic set of features allow you to get up and running quickly. Not only does this reduce the time spent on planning and developing features, fewer features let computational tasks run faster with a quicker iteration speed. One thing to keep in mind is we should start with simple models. It's tempting to start off with the flashiest new tech. However, this adds unnecessary complexity early on. It also increases the time to build the overall complexity of the system and the time it takes for new team members to onboard and understand the architecture. Meanwhile, simple models let you rapidly build the entire pipeline and build an MVP. Fourth point, understand and measure data before optimizing. A common pitfall is optimizing ML models too early in the life cycle. While parameters and hyperparameters need to be tuned, jumping too fast to that stage is counterproductive. An ML model is built by learning and generalizing from training data, then applying that acquired knowledge to new data to make predictions. Lack of data or unreliable data will prevent you from building a good model. The focus should be on requirements, selecting a performance metric, initial collection of data, quality identification, tying the metric to the business impact, gaining insights from the data to improve business impact. The fifth point, set up a plan to continuously improve and iterate over models. As previously mentioned, it's better off to start with only the essential features and basic models, then iterating and adding features. Not only do we need to iterate on the model based on the business needs identified at the beginning, there are other variables like changing business requirements, improved technological capabilities, major changes in customer behavior. The biggest recent example being the drastic increase in e-commerce volume because of COVID lockdowns. However, all of this requires a lot of in-house expertise in data science. This is not always feasible because of talent scarcity and budget constraints. So for such enterprises, there's a newly emerging way they can do it, that is through the self-service model, also called as AutoML model. There's a lot of hype around AutoML, and for a good reason. In essence, self-service machine learning is a type of AI that enables businesses to build models without relying too heavily on data scientists or IT experts. This way, it leads to data democratization since not all companies have the expertise or budget to roll out custom solutions. Self-service machine learning works by allowing access to ML algorithms and tools through a user interface. These tools allow business users to input data, train models, and analyze results. Since the training and deployment of an ML model is automated, it lets the business user without specialized skills concentrate on the data and find ways to add value. This approach has benefits even for companies that do have in-house DS teams, like Meesho. Data scientists no longer cram their schedules with integration activities like gathering, cleansing, and organizing data. Instead, they can employ critical thinking, solve crucial business problems, build extraordinary machine learning models, think up other use cases for AI, and find new ways to add value. So that's all from my side today. I'd like to thank everyone for your time, and it has been a pleasure to be on this stage and share what we have learned during our journey at Meesho. Thank you.
Thank you, Ravindra. Now, ladies and gentlemen, we'll move to the next keynote by T. Kim, Solution Lead Machine Learning Google Cloud. Let's understand from him how Google Cloud can enable organizations to build AI and ML models at speed and overcome lag time in development and experimentation of such models. Over to you, Kim.
Thank you very much for the introduction. Today, I'm going to talk about fast-tracking AI/ML to gain competitive edge. Let me explain a little bit about my team in order to share my technical background a little bit. I belong to Solutions and Technology APAC team. It's a team of technical practice specialists. So we focus on strategic customers in APAC. And my focus area is machine learning. And I focus more on large-scale machine learning and everything related to it, such as GPU, TPU, and Vertex AI. So when I was asked to present at this session, and it was pretty much thought-provoking, and the subject itself, the fast-tracking AI/ML to gain competitive edge. So we've been doing this from the very beginning, and look at the definition of what it means by fast tracking. So it's accelerate the development or progress of a person or project. So in terms of AI/ML, what does it mean by accelerating the progress of a project? So in the history of neural nets, we try to develop a better algorithm and better training algorithm and the neural nets architecture in order to solve the same problem, right? And when I started my my career in machine learning, so that was back in 2004. So during the second neural winter. So back then, the problem that we are facing was that collect data and then train the model and test the model. So we come back and forth between it. And then soon the GPU was introduced because we have a lot of data, and then the architecture, the model got bigger and bigger. So the advent of ImageNet and NVIDIA GPUs and VALU and these kind of things helped machine learning take off. And in 2013, deep learning has become one of the 10 breakthrough technologies. Still, the training the model is a very iterative and laborious work. So the problem at that time we had was we have to develop the code itself, and then because the data set is too large, it takes a lot of time to run each experiments. So in order to accelerate this process, what we have used is to use a specialized hardware for machine learning. As time goes by, the complexity has been increased. And at the same time, let's say we have the same amount of computational power. In order to have a better accuracy, we needed more computational power. So accelerators like GPU and TPU helped a lot to accelerate the progress of machine learning project. However, still, there exists the valley of death between research and development and production. So back in 2000 and 2012-ish, still the community of machine learning were tackling some POC problems. So we are handling those machine learning code and make it work and train the models and stuff like that. So back then, if I want to use a new algorithm, I have to develop a new algorithm by myself. I have to write C++ code. In order to do that, I have to understand the theory. and understand the paper. And if I have any mistakes in the code, I'm simply screwed. But these days, machine learning frameworks like TensorFlow, PyTorch, and JAX can help accelerate the time for the researchers and machine learning engineers to develop the model really quickly. And to start learning about certain project, we still have public data sets. There are a lot of them, and we can just download the data set and also certain models. And these days, sometimes it takes less than a day to reproduce some awesome works by other researchers. Let's say we have the model ready. We put a lot of efforts and also train the model. Then the next step is to deploy the model to the system. Actually, it requires a different set of skills and knowledge. So for my POC project, I didn't know how to build web server. So I have to learn the frameworks and then develop those web server by myself. And it delayed a couple of months for me because there is certain learning curve. So after the POC system, after joining to a company, now I have to work on some production system. I was working for a smart speaker, and wow. Even if we have the machine learning code ready, there are many things that needs to be done. That was way beyond the skill set and the knowledge of a machine learning researcher. So there is a hidden technical debt in machine learning systems. In order to tackle that, so a group of researchers, such as Google Brain, DeepMind, and other groups from Google, they have worked on this stuff. And we had an open source framework such as Kubeflow. So Kubeflow is a machine learning toolkit for Kubernetes. So in short, Kubernetes plus machine learning workflow. So it helps tackling the hidden, overcome the problem of hidden technical debt when we want to deploy the models to the production system. When the machine learning did not take off, or the deep learning was still at its infancy, the real challenge was to develop a working model. When that was ready, now the companies wants to use machine learning. So we have to bring it to the production level. So in that case, there were some delays and also the problems caused by making it to the production system. So in order to tackle that, a new field of study called ML Ops, machine learning operations, kicked off, right? So these block diagram shows the end-to-end machine learning workflow, and it can be orchestrated by using pipelines. So Vertex AI, we also provide pipelines. So Vertex AI gives you flexibility in tools you use to complete your machine learning journeys. So for training, you can use BigQuery machine learning. Also, you can do custom training. You can use AutoML and stuff like that. And also to deploy, you can use BQML. You can use the models in the batch mode, online mode. And after deployment, you can monitor that. So to define what is Vertex AI, it's a unified development and deployment platform for data science and machine learning. So basically, we have three different groups of services. First is pre-trained models for speech, vision, translation, and so on, and app platforms for conversational language vision. And the core of Vertex AI is to provide the ability to do your custom modeling and MLOps. So by using it, the problem that you used to have, so the training the model and serving it in the production system, that can be accelerated. So the lessons learned through the research by Google Brain, DeepMind, that was all put together, and also Google Cloud made the bridge to cross the valley of death, and as a result, Vertex AI is there. So by using Vertex AI, you can accelerate your progress in machine learning a lot. So the Google Cloud provides a large pool of services from the platform, Vertex AI, and some other AI solutions. And also, by putting them together in the proper way, so you can actually put some value and transforming those data into the business value. So after all those things that we have done by the machine learning community, so this accelerating the progress, there are so many options that we have. So Google Cloud is not the only organization that provides the solutions to you. There are other CSPs, and also there are some other companies working on MLOps and AutoML and stuff like that. So now many of those solutions have become unknown, and I'm not sure. When I was asked to present, what is the solution for the fast tracking AI ML? I have to ask myself, out of all those solutions that we have by Google, what might be the killer app? So after many thoughts, I came to a conclusion that Vertex AI is the service that can bring the competitive edge to many organizations. So from now on, I'm going to talk about Vertex AI. And in order to do that, we have to understand what is neural architecture search. So neural architecture search, or NAS, is a technique to automatically design the artificial neural network architecture. And it's an active research area since 2016, when Google Brain researchers published a paper entitled Neural Architecture Search with Reinforcement Learning. So the main idea here is use reinforcement learning to learn to improve the neural network architectures. And let's say if the reward is set to accuracy, the architectures that maximize the expected accuracy over time is learned from trial and errors. So Bellman equation finds a solution that maximizes the expected reward. And reinforcement learning is a machine learning algorithm, and the problems are formulated using Bellman equation. And we can find the solution via trial and errors. Here's an example, hill climbing problem. So here there is a car. Depending on the location where it is, it can either accelerate or deaccelerate. And the goal is to reach to the flag. So there is agent environment interaction. The car, there is an agent in the car, and the environment, there is a state, the location, and maybe the current speed. And depending on the actions that we take, let's say hit the accelerator, then we get the reward, right? If we do the right thing, we get the reward. Otherwise, we don't get any reward. Or even we may be able to, we can design the problem to get the penalty as well. So after lots of trial and errors, let's say we get the solution, go like that, and then get to the flag, right? So using this reinforcement learning algorithm, neural architecture search can find the solution with the maximum expected reward. And in the literature of AutoML or automated machine learning, the number of papers has been dramatically increased after Baretsov and Kroglu published the paper in 2016. So basically, what this NAS does in terms of the machine learning workflow is like this. So the green part, we do a lot of iterative process manually. So train the model and then test it over and over until we get the desired performance. Instead of doing that manually many times, what NAS does is it runs multiple experiments iteratively in parallel with sample architectures from the search space that was set by the user. So basically, on the left-hand side, the controller proposes certain sample architectures. And then given that, on the right-hand side, the proposed architectures are trained and evaluated in parallel with respect to the set performance metric. Just like this, we search the optimal solution via these two iterative steps. And to define what the neural architecture search is and what it does is it's a neural network architecture search technique. So that's neural architecture search. And it automates the design of the architectures. As a result, we have new network architectures. So this work has been done by many machine learning researchers manually over decades of years. So I showed you the history of artificial neural networks, right? So all those researchers who made breakthrough developed architectures manually, but with neural architecture search, you can find really nice architecture automatically. So let me talk about an example that blew my mind. So Waymo Google teamwork. The person on the rightmost side is Kwok Lu, one of the authors of the original NAS paper. And here there are two Googlers and two engineers from Waymo. They collaborated together to tackle the same problem. So what is Waymo? Waymo is a self-driving car company. And So this case shows that Waymo's machine learning experts generated models manually for months, and they collaborated with the Google researchers, and NAS generated and fine-tuned the models automatically. In the figure on the left-hand side, the black dot shows where the model that was created by Waymo machine learning experts. So x-axis is latency and y-axis is proxy model quality. You can think of it as accuracy. So here, when the accuracy of the model is higher, it's better. When the latency is smaller, it's better. So in the figure, the left top part it's good, right? And the right bottom part is not very good because it's not very accurate, but it takes a lot of time to compute it, right? By using NAS, one dot corresponds to one machine learning training. And as you can see, there are so many dots. So so many experiments were run by NAS automatically. And by looking at the figure on the right-hand side, we were able to find, not actually we, but they were able to find the boundary of the performance. So all they have to do is just pick the right model, right? So by doing this, the NAS searched over about 10,000 architectures in 2 weeks, which corresponds to 1 year of GPU time. And the performance improvement was done by about 8 to 10% lower error rate, and also 20 to 30% lower latency given the same quality. So it's an amazing work. And the example of the architecture found by this proxy end-to-end search looks like this. So this is a CNN or convolutional neural network based. So if you know how the manually designed CNN architecture looks like, this is very creative combination. Typically what is done is given the convolution layer, pooling layer, convolution layer, pooling layer, and goes on and on. But this one is quite different. It combines convolutions, pooling, and deconvolution operations in a very unique way. And also, this architecture ended up working very well for the original LiDAR segmentation task. So if you are interested in the details, please refer to an article entitled AutoML, Automating the Design of Machine Learning Models for Autonomous Driving. So that was a single example that NAS was very useful for a research case. And also, actually, it's not only for the research case, because this the model that was found will be loaded to the autonomous vehicle, right? So let me talk a little bit about why Vertex NAS. So usually training performant models is very expensive, time consuming, and very challenging. So users find value in NAS when there are some heavy reliance on the next state-of-the-art model to be published before any progress is possible, and hand tuning is no longer sufficient to meet some requirements. As an example of the Waymo, the requirement is not only for the accuracy, but they also have to consider latency. So it becomes a multi-objective optimization task, and it's quite challenging, right? So using NAS, they were able to overcome the month of effort in 2 weeks. So another case that is useful is the time to market is critical. because you can develop the model pretty quickly. So we can release the model in time. So by using Vertex NAS, you can increase productivity. Instead of using the in-house AI, developing an in-house AI model, which may take a month. So by using NAS, you can reduce it to weeks. And you can also achieve very high performance. And machine learning experts can explore new ideas faster and build the best-in-class AI models. You can reduce time to deploy by designing application-specific models, because you can set different requirements for this application. And let's change the requirement for the other application and the other one. Typically, it's very time-consuming because the researchers have to just train it and set the architectures and set the hyperparameters manually and run it over and over until they can get the model that satisfies the requirements. But NAS can handle that automatically, so we can reduce time, right? So by doing that, you can design models to achieve the best accuracy within the target budgets, such as latency, memory, and power too. I think I have to say this. In order to present here, I got a permission from the PM of who is in charge of neural architecture search within Google. So it has been, this service has been private preview, and it has been disclosed to very small number of customers. And there was a qualification process and stuff like that. But I heard that these constraints are being relaxed, and so you may be able to use NAS more freely. So it'll be GA'd soon. So please wait for the announcement. One of the reasons I think why NAS has been provided to only a small number of qualified customers is that NAS is how Google is building the current state-of-the-art models. So in the figure, so there are some hand-designed architectures like Inceptions, ResNet, and so on. And the recent breakthroughs, NASNet, AmoebaNet, MNet, stuff like that, those were trained and built using neural architecture search. Let me share some examples that NAS achieved the state-of-the-art in computer vision tasks. From the left, image classification, object detection, and image segmentation. So in all figures, x-axis is flops, floating point operations. So that means the computational power, and y-axis is top-on accuracy, and AP, average precision, and mean intersection of union. So basically, the y-axis is the performance, the accuracy related metric. Again, when the models are on the left top corner, that's a good one. And if it's on the right bottom, that's bad. So moving on to the image classification here, the green part. So ResNet, Inception, ResNet, DenseNet, and so on. So these are all developed by machine learning experts. and the efficient net and amoeba net that has a significantly smaller computational power, but achieving higher accuracy, they are built using neural architecture search. And the same is true for object detection. So the SpineNet for object detection and NAS FPN, feature pyramid network, those for the image segmentation, those are all built by neural architecture search. So the NAS framework is explained in this slide a little bit in order to give you some insights how it works internally. So you set the search space on the left-hand side, and the rest of the work will be handled by the reinforcement learning on the right-hand side. So the controller proposes some sample architectures, multiple architectures, and trainer trains the model and gets the accuracy. And we set, let's say, so this slide, the metric is set to accuracy. So the reinforcement learning improves the models given the reward structure over here. So there's a loop. As time goes by, reinforcement learning improves the performance over time. So NAS is also the state-of-the-art for on-device and low latency AI. So the example was shown for the Waymo case, but on the let's see on the left-hand side, the image classification, the x-axis is latency, the y-axis is the x-axis is latency and y-axis is the accuracy, right? So NAS can be used to achieve the state-of-the-art for on-device AI. This slide shows the case that multi-objective optimization is done by neural architecture search. The difference is that on the right-hand side, there is an inference module, and also the single objective module in the bottom has been changed to multi-objective. Instead of learn over the single objective of accuracy, here we have multi-objective both for accuracy and latency. Given the reward structure, NAS learns the best architecture that can satisfy these two performance metrics over time. So this is the web UI provided by NAS. It can be used to analyze the search results. So the x-axis is latency and y-axis is top-on accuracy. And one dot corresponds to a single training. So as you can see, there are so many experiments are run in parallel because we have run so many experiments over a single NAS experiment. It's possible to have some intuitive idea about what might be the top models given the situation. So typically, it's quite challenging and difficult to grasp those intuition, even for the experienced machine learning people. But this tool provides a very intuitive web UI, so even a novice can see it and pick the best model very quickly, right? So let me quickly summarize what is a vertex NAS And Vertex NAS is a service that lowers the bar of neural architecture search for machine learning experts. This is not for everyone. It's designed to target the machine learning experts. And it provides very flexible platform. You can set the search space and let the system or the platform learn over time and find the best architecture for you. So it searches the new architecture, and as a result, it reduces time for model training. And also the performance metric can be set for a single objective to multi-objective optimization, including accuracy, latency, memory, and power. There are some pre-built search space, and we also provide a code. And in there, these metrics are provided. But if you would like to use those platform and want to set a new metric, you can also do that. But in order to do that, you have to use the custom search space. And for that, you need some experience. So we advise you to start from the pre-built search space. So the thousands of training and evaluation tasks can be run in a single NAS experiment. So in order to, it can cost from $5 all the way up to several $1,000s. So because it runs very expensive GPU experiments in parallel, depending on how you set it. So it's not for everyone because it's very expensive, right? Tens of thousands of dollars can be easily consumed within a couple of days. So you don't want to play with it. Yeah, just in vain, right? So there are always trade-offs between the cost and the performance that we provide. So, but if you have some advanced machine learning people in your institute, and if you'd like to learn more about it, so we have the customer engagement process. So what I talked about was at the very entry level, the deep dive contents. So we can host the full deep dive session, workshop, and you can go through the POC and stuff like that. So back to the original question that I have, how can we fast track machine learning projects and yet gain some competitive edge? There are so many solutions out there. And Google Cloud is one of those companies that provide the solution that can accelerate the progress of machine learning projects. But I think this neural architecture search can provide the competitive edge, and it is one of the key differentiators. I am in the field of neural nets since 2004, and I was very much thrilled and excited about neural architecture search. And it was like the dream technology for me. So I highly recommend you to consider using that if you have some mature machine learning community in your organization. Thank you very much.
Thank you, Kim. Now, ladies and gentlemen, it's time to answer your questions. I'll pick the questions and pass on to our esteemed speakers. Let's begin the Q&A round. Now, ladies and gentlemen, it's time to answer your questions. I'll pick the questions and pass on to our esteemed speakers. Let's begin the Q&A round. And I hope you all like the content shared by our esteemed speakers. And now it's time for interesting Q&A session. So, gentlemen, are you all ready to take the questions?
Yep.
Yes.
Okay,
Happy to take the
Yes.
questions.
perfect. Let's start with Ravindra. Our first question from the audience is how AI affect digital payment or online transactions in recent times?
Got it. So, if I understand the question correctly, uh, it's basically trying to figure out how AI is solving problems which are there in uh, digital payments, right? So, if you look at it from a broader point of view, there are mostly two problems. Successful transaction is something that is needed. Second is genuine transaction, right? So traditionally, when banks or the payment gateways enable payments, they would select three, four different banks, and they would select these banks in a uniform way. And if the success rate of, say, one of the banks is going down, they are not able to react as fast, right? But with AI, now we have capabilities to identify the trend of success rate going down or up for a given channel, given bank. And in real time, these payment gateways are able to course correct and divert majority of their traffic to the more successful ones, right? So this is one way AI is helping uh, make more successful transactions. The second part is making genuine transactions, right? And when I say genuine, basically in e-commerce space, if you look at it, there are a lot of fraudulent transactions that happen, right? Where people would use stolen credit cards, or they would try to game the payment in some other fashion, right? Now you cannot catch those patterns as easily. A better way to solve this is basically look at the actor, uh, whether he's a good actor or a bad actor, a user or a payment instrument, right? Look at the historical features, right? The phone number or the email ID associated with those accounts. And historically, if there has been certain uh, fraudulent transactions from those accounts, those entities, then in real time, AI can help flag these and put transaction on hold. And then there are other steps to kind of moderate that process and uh, and fix this leak which is happening. Right? So these are the two ways uh, or two problems which are being solved by AI.
Sure. Next question is for Kim. In the real world, we are not getting text data in most cases. We are getting images or PDF documents with lots of variations. Provided this scenario, developing a generic model to extract information is becoming a challenge. Business needs speed to market product. How to overcome it? Over to you, Kim.
Yeah, thank you very much for the question. So it looks like you are asking a case that you need to develop a machine learning model that can extract data, text data from PDF file. But to me, it sounds like I'm not sure if this is the correct approach at the moment. Usually, when we think of the machine learning workflow, we assume that the text data has been prepared. Before for that process, we typically go through data cleansing and EDA and some preparation processes. So using machine learning model may not be necessarily the best practice. But there's a lot of ways to interact, to extract and prepare text data from PDF files. So maybe our the speakers, Ravindra, may be able to address this in a very efficient way. Ravindra?
Sure. Yep.
Yeah.
Thank you, Kim. I think at a high level, you explained the solution well. So in AI space, if you look at any model, the model has to work with numbers. They cannot work with anything else. numbers, right? And then if you look at what is closer to numbers, so texts are in a way closer to numbers rather than PDFs or images or videos, right? So any AI practitioner first tries to bring any data set into the format of a number, right? So I'll give you examples. So if you are talking about a PDF, right? So how do you convert that into a number? And then you can, of course, on numbers, you can create your classifiers or regressor models, right? So in case of PDF, uh, you can build a pipeline where the first step is running an OCR, right? Which basically would extract out the text out of your PDF. If it's a text document, and then on that extracted text, you can run a word to vec model, which would convert it into a mathematical vector, a number vector, right? And then you are free to use any model. If you are using, say, image, right? Now there also the problem is to convert that image into something which the model would be able to understand, and that is essentially a vector of floating point numbers. So we have models, deep learning models, off the rack. You just pass your images and it would give you a fair representation in terms of a vector, right? Similarly for videos, right? If you are getting a video data, so there are two things there. One is audio, other is video. So in audio, what you can do is you can convert the audios into from speech to text, right? And you have a text data, and then you convert it into a vector, number vector. When it's a video, you basically break it into multiple frames, and each frame is an image. Now you have image, you pass it via some deep learning model, it would give you a mathematical vector, right? So essentially, there are two steps. First step is transforming your data, which is a non-textual format, into a textual format, and then converting it into a vector format, data number format, right? After that, you can apply all of your traditional algorithms, your regression algorithms, your classifiers, or reinforcement learning algorithms, right? So that's how typically practitioners approach EDA and data cleansing and data transformation for the models to work on it. I hope it clarifies. Annie, you are on mute.
Okay. I hope that our audience got the answer, as two of our esteemed speakers, they gave answer to this question. Now let's take another question. We have this question for Kim. With respect to clinical data, how do you overcome the PHI de-identification, that is PDF or image data, issues for getting training data faster? Kim, would you like to take this question?
Yes, sure. Thank you very much for the question again. Let me first clarify if I understood the question correctly. So you mentioned PHI de-identification. So to my knowledge, PHI identification, so PHI identifier is the protected health information in the medical record that can be used to identify an individual. If that's correct, PHI de-identification issue sounds like a problem to find where the PHI identification information is, and then conceal this information, maybe for security reasons and whatever. And you also asked that how you can overcome the PHI de-identification problem from PDF and image data. Let's say, so if we convert this problem to machine learning, let's say, given an image or PDF file, I would say we don't deal with PDF file directly. So I'm going to convert it to an image file. And then we have a uniform, so for both cases, we have image input data to a machine learning model, right? And then the question becomes, we identify where those PHI information, so identifiers are located, and then what that is. So maybe we can convert this to a OCR problem, or we can convert it to object detection, image classification, and localization problem. And there are many ways to address this. But to me, it sounds like first we have to, so to summarize, I think we first have to convert those source information into image, and then apply either OCR or other computer vision task things. So yeah, so that's my opinion from the machine learning perspective, and maybe another speaker, Himanshu, have some other opinions. Himanshu, can you add some of your opinions, please?
Yeah, it's a tough one. So basically, once something has been de-identified, like you still want to keep on leveraging that. One thing probably like you can do is some of this information which before you have de-identified, like you can hash them, keep it, so that you're not at risk of revealing them, but at the same time you can run certain things and compare that to hashes and see how close was it to the previous one. That could be one of the things that I can think of.
Sure. I hope that our audience got the answer to the question. And wow, we are really enjoying this Q&A sessions, and our speakers are really enjoying answering the questions. So now let's move on to the next question. We have this for Himanshu. You recommended using human in the loop as a safety net. Can you give us some examples? Over to
Oh,
Himanshu.
absolutely. Sure. Uh, so basically, like what you, and this will totally depend on what you are using this for. For our business, basically, my ability to go wrong while predicting something was very limited. See, it's not about like what I just told you in my session as well. It's not like when I say like cab will reach in 15 minutes, your expectation is if even if it happens to be 18 or 20 minutes, it doesn't make sense. I'll be doing financial calculations. So if I say like I'll be giving you 78,000 rupees, and instead of that, I give you a standard deviation which is like double, and I pay you either like 36 or 150. I'll be out of the business, or you will be making more money, as in the customer makes more money. So based on the business and the use case that you have, I would say like you can build those safety nets when, and especially when in doubt, send it to human. You can find some heuristics around like, so like I still send every 10th transaction being predicted by my models to a human, just to see that what I am predicting still is working, not at end of day, but on an hourly basis, and build those safety nets so that the moment you are not hitting those thresholds, you can move to fully human loop, fully human, and then see like what went wrong, and then retrain it. I would not for sure recommend taking off your eyes from what it is predicting, because by the time you realize it, like it would have been extreme. You would have created an extreme damage. So I would suggest like when in doubt, just send it to humans and let them validate. Once you are sure, just put it into production and make it 100% automated.
Sure. Moving to the next question. What is Meesho's AI model strategy? What difficulties do you anticipate in selecting an AI model and extracting results? For sure, this is for you, Ravindra.
Yeah,
Over to you.
sure. So at Meesho, we are extremely data driven, right? So a lot of our decision making is based on the insights that we get from data, right? Now we leverage data to identify the right problem statements, 10x opportunities, and then figuring out the right solutioning, the feasible solution for that, right? Now, in this process, you could have, let's say, 3 or 4 different solutions which might work, right? So when we bring in AI for these solutions, we end up creating different models for each of these solutions. Now, the main problem comes in choosing the right solution out of these four, right? So there are two different ways you can arrive at the right solution, the most optimal solution. So one is you do some analysis on backdated data, do some back testing. The other way is to do live A/B testing on your users, right? So we practice both. So we do back testing a lot to narrow down on the final three or four variant of models, and then we go ahead and launch A/B experiments on our user groups, and we run that for some stipulated period of time, and then we measure for the metric that we want to optimize for. Whichever model is performing well on your North Star metric, as well as it's doing fairly well on your check metrics, you choose to deploy that, right? So you'd want to scale that solution to 100%, right? So this is the approach we take at Meesho for solving any problem which has to be solved by AI.
Sure. Moving to the next question. This is for Kim. What is the outlook for AI growth in 2023? Over to you, Kim.
Annie, can you repeat the question again?
Yes. What is the outlook for AI growth in 2023?
2023. Wow, that's a tough question.
Yes.
Yes. So I am not. I may not be the right person to answer to give you the perfect perspective about next year. But let me share some perspective from my side. So here we can define the growth in several different aspects, right? Growth in, let's say, in market, and growth in, let's say, the expansion from the IT world to, so this, if in terms of the digital transformation, and also we can consider growth from, let's say, the technology point of view, and many things. For the first two, I don't think I am the right person to show. I am not the sales person. I focus on technology. So let me talk about some of the technology side. For Google Cloud, we definitely have had growth from many areas. Let me. One concrete example is in terms of TPU, or tensor processing unit. This year at Google I/O, Sundar Pichai has announced Google TPU version 4 pod. So that's the fastest public supercomputer with very limited, very small use of power consumption, and it's very eco-friendly as well. So this is one example of Google Cloud's has for the growth in terms of the computational power, because we are moving from TPU version 3 to version 4 and so on. And also the Vertex AI, which is the unified solution for machine learning and data science. We are adding more features. So there are many new features, and let's say I actually give a talk about what's new in AI at one of the key events. Annie, is it possible that I can share the link later to the public, to the audience?
Sure.
Yeah. Then I'm going to present you. I'm going to give you the link to my talk, and there we have the highlights on 2022, and actually which can be expanded to 2023. So that's another aspect for growth from Google's perspective. And from the research point of view, let's say we have 3 or 4 main areas of data sets. So for the image, text, speech, and also the structured data or tabular data. So for recently, large scale language model has been the major hit, and it brought the many breakthroughs in the field of machine learning. And so the trend for this large scale language model is that the size of the language model or the model capacity has been growing dramatically year by year. And so let's say GPT-3, for example, it has been the recent for the large scale language model, and there are some other things like a T4, and this year Google has announced PALM, Pathways Language Model, and stuff like that. And in terms of growth of the model size, it's been growing dramatically, and every year and year, so it's also getting bigger. I have a lot more examples of growth from the technology point of view, but maybe let me stop at this point.
Sure. So let's take another question. This one is for you, Ravindra. The question is, you talked about the difficulties in deploying the model. What is the reason why scaling a deployment across the organization is a challenge?
Right. So mostly deployments in large organizations are handled via an engineering team, because the capabilities or skill sets that data scientists have are a bit different from engineers. So they are good mathematicians, statisticians, but they are not as skilled as engineers in terms of deploying models, right? Now, if you are building an AI solution, the data transformation and modeling, all of these are done by data scientists. Now, to enable that to be served at web scale becomes a challenge for the data scientist. The data scientist needs to work with engineers, provide the right context, how this has to be solved, and then engineers are supposed to translate that requirement into a model serving framework, right? Now there are chances of certain things getting amiss, right? There could be certain gaps in terms of training and inference time, right? So we call that as a uh, training and serving skew, right? So the data that you use to train your model and the data that you use to infer, right, might be slightly different. There could be certain gaps which might creep in because your pipelines are in different pockets, right? So you train your model in a batch setting where your data is available in some Delta Lake or in some files, but while you are inferring it in real time, your data, your features are coming from different real time systems itself, right? So making sure that all data points are available at once and you are able to infer that within milliseconds to take the right action, that is another problem that data scientist needs to solve via engineers, right? So the span in which a model manifests, right, it's huge, right? You have to work with business folks, product folks to design your model, build your models, and finally engineers take it into production, right? So because of this span, it's difficult to make that collaboration as efficient, right? And that's the problem these large scale companies face when they're trying to deploy their models in production, right? And of course there are solutions to it as well, right? So there are ML platforms built, right? So you can use ML platforms from AWS and GCP, which would make all of these deployments as one click deployment. Your model is there and you just do certain configs and you click, and then uh, your endpoint is available to serve models. It's auto scalable, it's logging enabled, monitoring enabled, right? So those solutions are also there, right? But the first part is basically identifying the problem, whether you need to invest in right ML platform or you can make do with your engineers itself, right? Is something that the companies have to take a call, right?
Sure. Next question. Uh, so we have this question for Himanshu. You also mentioned GPU and TPU are better choices over CPUs and recommend using them. What do you choose, GPUs over TPU and vice versa?
Sorry.
Himanshu, this
If
one
you
is for
have
you.
a, sorry, I was unmuting myself. See, like, totally
Sure.
depends on the resources that are available to you. So, see, if you are not on GCP, TPUs may not be available. So, for sure, like GPUs are any day better than CPUs, but you have to take a call. And GPUs will work. It's not that like if you have access to TPUs, GPUs are the right choice. So, TPUs are best suited when you are training with large data and but if you want to scale up, so there were two things which I picked up from Ravindra. So like for data sciences, probably TPUs if you have it, it's great. But if you have to scale up, then GPUs are the better thing. So like if you are going to like bundle them into Docker containers and then just do like a lot of compute which is parallel in nature, just get onto them. But again, it's a choice of platform. So if you are an on-prem, then you may not even have access to TPUs. But TPUs, the word stands for tensor processing unit. So they are meant for optimizing. And Tim also mentioned that Sundar Pichai announced like a next version. So which basically they have a job to do. So they'll keep on scaling and keep on making life easier for most of the engineers. So I think if you have access, neural network, TPUs or GPUs, TPU being first. If you don't have access, then you have to live with GPUs and CPUs only. But for sure, parallel, like the kind of data you are going to handle, it's going to be parallel both at training level as well as serving level. So I think if the choice is there, go for GPUs.
Okay. So I hope you have answered to your question. Moving to the next question, this is for Tim. So you talked about the major history of how the ML community strived to gain a competitive edge and Vertex NAS as a way to accelerate the progress of a ML project. The intuition I got from this talk is the methods to fast track AI and ML have been changed over time. In that context, how do you think Vertex NAS will remain as a method of fast tracking AI ML? Over to you, Kim.
Yeah, Annie, thank you very much for the question. It's a question, and also thank you very much for summarizing the major points of my talk. So here, yeah, it's about the future, right? So I can't really predict the exactly how long this Vertex NAS will remain as a killer solution. It depends on the market. It depends on the how quickly the technology evolves in the future. But I can say for sure that for the next couple of years, if you use it in the proper way, the NAS will be able to bring you a competitive edge to your organization. Sure. For the further up, not sure. In a sense that, let's say, So NAS is really great product. As I talked about it in my talk, it's a dream technology to me. Yes, it automates things, but the disadvantage, I can't really say it's a disadvantage, but there are always pros and cons. And the con, let's say it's a disadvantage. It's very pricey. It's very expensive. So it's not available for everyone, right? Until it remains very expensive and accessible to a small number of, I would say, the premier customers, you can still have the competitive edge by developing really performant models. But let's say it has become a norm among many organizations. So let's say everybody is using NAS, and it's very then it may be hard to get some competitive edge over other organizations, right? So that's my answer. But before I finish my answer, let me ask you a question. So the key components of deep learning, such as multi-layer perceptron, backpropagation, and CNN, and later we've got transformers and stuff like that. As your organization have developed one of those, the cutting edge model or algorithms, then you had the competitive edge over other organizations, right? So just like this, will you choose NAS in order to get the competitive edge or not? Or maybe another question might be, are those key components of deep learning, are they useless these days? No, right? They still work as the key components. So to get to the point, how long it'll remain as a method of fast tracking AI ML. It automates the process of training the model, so you will still have the competitive edge. But the question is how much value you can get out from it compared to the other organizations around you.
So there's one more question that is connected to Vertex NAS. It says, say we are interested in using Vertex NAS, what do we do to use it? Any suggested steps that we have to take to use it?
Oh, yeah, thank you. I actually have mentioned this in one of my slides. So let me quickly revisit one of them. Let's say. So this question is about the engagement process. So the NAS team has the NAS customer engagement process. So that's, can you see the slide? Can you turn on the slide? Is it possible to share? Yeah.
Yes.
So awesome. So this is slide 52 in one of the, in my talk, and the upper part is saying that Vertex NAS is not for everyone and you have to balance between the price and the performance, right? And in the bottom part, the NAS customer engagement process is depicted. So the first step is NAS deep dive. Second step is NAS workshop. And the third step is NAS trial or POC. So if you are interested in using Vertex NAS, you can contact Google Cloud's salesperson, FSR, or field sales representative, or KAE, key, KAE. Key something executive. Sorry about not remembering the acronym correctly. But so you can first contact our salespeople, and they will they'll work together with the account CE and then AI/ML specialist, and then engage machine learning solution lead. So my role is machine learning solution lead. So we can work together to explain you how NAS works. So first, deep dive basically gives you the overview of what NAS is like. So today's talk, my talk, is let's say about 1/4 of the deep dive. So we can explain, give you some overview about what NAS is like, and then if you are satisfied with the requirements and what we can deliver to you, we can give you the workshop. This is basically like we explain the user guys in a very kind and nice way, because NAS is a very complex and difficult in theory, from the theoretical part. So maybe you can do it by yourself, but it may be easier and the result will be faster if we deliver the workshop to you first and then move on to the POC part. So we used to have very strict constraints, and so this is actually hidden. The user guide is hidden, and if you'd like to find Vertex NAS and do some projects, you actually have to be whitelisted by the NAS team. So we can help you with this. So the NAS team will allow you to use and access those NAS project, and also allow you to access to the user guide, and also predefined search spaces and some source codes and stuff like that. So that was my answer. And Annie, previously I talked about what's new in AI/ML, right? So I just in between I look up those information and put it in the chat room. So basically, yeah, this talk I was presented at Data Cloud and at Applied ML Summit 2022, and also slide deck is available, and so it's available on YouTube. So if you're interested in, you can take a look at it.
Sure. So that was it, ladies and gentlemen. We are running out of time and we won't be able to take any more questions. Thank you so much. I hope you all enjoyed this Q&A session. Thank you, Kim. Thank you, Himanshu. Thank you, Ravindra, for this wonderful content. I thoroughly enjoyed the whole session, and I'm hoping that our audience also enjoyed the session. Thank you to all of you. Thank you to our audience for being so interactive and patient. And finally, thanks to Google Cloud for this collaboration. Ladies and gentlemen, keep following ETCIO for all the latest updates and upcoming events. Take care and stay safe. Thank you, gentlemen.